Good evening, everyone. Welcome to the Centenary Celebration of the Department of Mechanical Engineering, IIEST Shibpur. Today, we are here for the 10th Centenary Lecture under the Centenary Lecture series by our Honorable alumnus, Professor Amaresh Chakrabarti, on the topic An Overview of Industry 4.0 and its Implication for Design and Innovation and Growth. The session will be chaired by Professor Sanjay Gupta, Professor in the Department of Mechanical Engineering, IIT Kharagpur. Sir, please take over.
Is he unmuted?
Yes. Thank you for inviting me to chair this session. Thank you for the organizing committee of the Centenary Celebration of IIST Shibpur Mechanical Engineering Department. Well, I would like to introduce Professor Amaresh Chakrabarti, who is the speaker of today's lecture, lecture number 10. An overview of Industry 4.0 and its application for design-led innovation and growth. So briefly, I will introduce Professor Chakrabarti to the August audience present online in this lecture. So Professor Amaresh Chakrabarti is a senior professor and current chairman of the Center for Product Design and Manufacturing, Indian Institute of Science, Bangalore. He obtained his bachelor's degree in mechanical engineering from Bengal Engineering College, Shibpur. It was then under Calcutta University in the year 1985, and he was incidentally the topper from the department. Subsequently, he completed his master's in mechanical engineering, mechanical system design from Indian Institute of Science, Bangalore in 1987. Dr. Chakrabarti earned his PhD degree in engineering design from the University of Cambridge, United Kingdom in 1991. Now, he led the design synthesis group at the European Physical Sciences Research Councils, which is popularly known as EPSRC, Center of Excellence Engineering Design Center at the University of Cambridge for 10 years. His interests are in synthesis, creativity, sustainability, informatics, and Industry 4.0. He has published 17 books and over 300 peer-reviewed articles. He has also obtained, 11 patents were granted to his credit. He co-authored design research methodology, which is widely used as a framework for design research. He incidentally founded the Ideas Lab, the India's first design observatory. He is the first non-American editor-in-chief of Artificial Intelligence for Engineering Design, Analysis and Manufacturing, a 35-year-old journal from the Cambridge University Press. He has been an associate editor of IIEDAM, an engineering design journal, area editor of Research in Engineering Design, regional editor of the Journal of Remanufacturing from Springer, and advisory editor for 8 journals, including Clean Technology and Environmental Policy, Material Circular Economy, Springer, Journal of Engineering Design, and International Journal of Design, Creativity, and Innovation. He was a member of the Advisory Board and Board of Management Design Society, a member of CII National Committee for Design India, a jury for India Design Mark, and an invitee to the CII Smart Manufacturing Council India. He is program chair for International Conference Series on Research and Design, Research into Design, 22nd CIRP Design Conference 2012, Third International Conference on Design Creativity 2015, and Vice Chairman for AI in Design and Design Computing and Cognition Conferences. He is an honorary fellow of the Institution of Engineering Designers, the highest honor of the Peer Society under the UK Royal Charter in Engineering Design, and TUM Ambassador Awardee from TU Munich, Germany. He co-initiated India's first smart factory R&D platform. He also heads IISc TCS Innovation Lab, IISc Press, and the Springer International Book Series on Design, Science, and Innovation, and chairs the Smart Manufacturing Standards Subcommittee of the Bureau of Indian Standards. He received Career 360 Faculty Research Award 2018 for being the most outstanding researcher in decision sciences. He is also among the global top 1% of researchers in design practice and management. Professor Chakrabarti, the stage is now yours.
Thank you very much for your introduction. And let me start by, first of all, congratulating the Mechanical Engineering Department for its centenary celebration. There are not many mechanical engineering departments in the country that can boast this. And I am really honored and humbled to be invited to give this lecture here, and also proud to be an alumnus of these departments. So my sincere thanks to all of you. So let me start my my talk. I'll just share the slides. Okay, right. So I need to. Okay, so can somebody confirm that the slide is visible?
Yeah, it is visible. Yes.
Okay, okay, thank you so much. All right, so let's start. So let me go back in history a little bit and weave a story to talk about the past a little. So India in the 1800s, and India in the 1800s were one of the leaders in manufacturing, the other being China. And in particular, I'm talking about the story of steel manufacturing. India was at that point of time leading manufacturing of steel. Of course, they were a leader in gem manufacturing, ship manufacturing, and several others. So UK was the leaders in steel manufacturing, among them India.
You may like to go for full screen.
I am in full screen right now.
No.
It's not coming full screen. Maybe.
Okay, let me try again. Please
maybe
confirm
it's some
that.
other window.
Yeah.
Okay. Are you able to see it full screen now?
No, no, no.
Not really.
Okay. Is it full screen now?
No. Same. I think that the screen that is shared, that is not really operating. Or maybe you have shared window this time?
I have shared the window, yes.
No, if it's a shared window, then it might be better to go back and share the screen.
Okay.
Sorry to disturb you.
No. I think you need to do that. Otherwise, stop sharing. Okay. So I go and share Earlier also I shared the window. Shall I share the screen?
No,
Yeah.
no screen. The on leftmost part you will find the screen one.
Yes. Shall I share that?
So that will, yes.
Okay.
Yeah. Now it's coming, and now I think you can go for full screen mode, either by using F5 or by using the
Yes.
Excellent.
icon. Yeah, it's coming full screen. Thank
Yeah,
you.
I'm sorry. Thank you. Thank
Please
you
go
for
ahead.
guiding me. Yeah. Okay. So going back to that, India in the 1800s, UK was the leaders in steel manufacturing, India, and particularly to find out what is it that they were doing that UK was not doing. And they found a very highly efficient and skilled manufacturing process, but they found also that this was not scalable. And what they did riding on the industrial revolution, the first industrial revolution, they made this scalable, and over a period of time, in combination with technological advances and political acumen, they made themselves the leaders. Now, fast forward to Germany after World War II, they were in tatters and visited the manufacturing leaders, including UK, once again to find out what is it that Germany was not doing that others were doing. And one of the things that came out of that is that there was a gap between industry and academia in manufacturing, and this is something that they needed additional effort to bridge, and they came up with the Fraunhofers for translational research. Now, in the 21st century, UK, interestingly enough, is revisiting manufacturing. About a couple of decades ago, they looked at that and said, what is it that the leaders, such as Germany, were doing that they were not, and how can they move up the value chain? And based on that, they figured out that translational research, not only translational research, but also innovation is important for this. And they created what are called catapults, which are centers of excellence in translational research and manufacturing innovation. Now, time has, of course, come for India to look at itself and say, well, 300 years down the line, how do we reclaim our position back in the areas of manufacturing? And how do we move up the value chain? And there are several learnings that have come and several transformations that have happened since the way manufacturing used to be conducted in the 1800s. First of all, manufacturing has expanded itself from essentially transformation of materials to manufacturing centric life cycle. So it goes all the way from making materials and down to making products, and then bringing them to end of life. One interesting example is the way in which, for instance, somebody like Rolls-Royce, which makes engines, aircraft engines, conduct their business right now. So instead of saying that I'm going to sell you an engine, they are now saying that I am selling you power by the hour. So I am guaranteeing that you continue to get power, and whether and whatever is necessary for that is something that I'm going to provide you. So it is really a product life cycle, a product service system that they are providing rather than just a product. Research and technology, the mad scientist sitting in the corner and creating inventions, has given away to a team of people that are working together in order to innovate and take it down to the society through entrepreneurship. Individuals' activities have given away to an activity by the ecosystem. It's a combination of people, material, component, technology, product, platform, supply chain, and business that together will make technologies come all the way down to the society and make a difference. And importance of design as the invisible king has arisen. That it's easy to see something is happening when metal is being cut, but it's much more difficult to see that the decision to cut the metal happened much earlier, when hardly any money was being spent. And that's something that for a long time got missed out and is beginning to be understood as you go along. Finally, the role of training and education at all levels is being felt as never before. It's not just getting either higher education done, but both the white collar and the blue collar members of the society, all the way down to early educational levels, are important. and the importance of R&D infrastructure and support, as well as putting long-term goals in order to create the knowledge with which industry and practice can be supported further down the line is also being felt. So that we can provide flexible scale manufacturing that is affordable and of high quality. Flexible scale is very important because not always you will get economy of scale. So you need to see, can I provide manufacturing for the right number of cases that I need? And in order to do that, we also need to provide flexible scales training and rapid updation that is also affordable and quality. So for a country as big as India, I think these are particularly important. And for doing that, Industry 4.0 is important. So let me come to Industry 4.0. I'm reasonably sure you all know what Industry 4.0 is. So therefore, I have only put one slide on talking about it. And if you look at back at history, and this is one view of the history as it has passed, manufacturing went through four historic transformational phases. The first was at the end of the 18th century through the first industrial revolution, where one introduced water and steam powered mechanical manufacturing facilities. James Watt epitomized that. Further down the line, start of the 20th century, a second industrial revolution came where electrically powered mass production and also division of labor were introduced. Further down in the 70s, computers and electronics was introduced, bringing in individual automation in manufacturing. And what we are talking about today is a transformation from automation to autonomy, riding on the revolution in information technology, artificial intelligence, and so on. One is dreaming up a situation where all the elements in an organization, including for the case of manufacturing on a factory, are connected to each other, and therefore autonomously they can decide the state of the system and what can be done to make it improved. So if you look at the essential elements of Industry 4.0, and I'll skip the definitions and so on, essentially automated and data connected manufacturing technologies, where services, data, process, systems, and production assets are all connected with each other, and they can take together decisions. But what are the specific elements of such a system? The first is that the objects and components that are there in the system are self-aware. In other words, data is possible to be collected about them. So sensors become important in this case. Second is that they are connected to each one another. So communication network becomes important. This data is continuously stored in real time, typically in cloud, and autonomous analytics can be done on it in order to decide, to monitor, to diagnose, and to correct. So in addition to that, there is also new design, manufacturing, and communication technologies that are coming, some for simulation, some for additive manufacturing, more increasingly hybrid manufacturing, robots, collaborative robots, and so on. What are the key benefits that are talked about? Efficiency, decisions are faster, and so on. Agility, easy to move, easy to adapt, greater innovation, greater customer experience, lower costs, and greater revenues. But of course, also challenges. Cybersecurity is a major concern. Skilling, reskilling, upskilling of workers at all levels are important. General reluctance to change is another issue. IT plays an increasingly important role. Therefore, snags will become costly, and then issues of reliability and stability of all of these communication networks become critical. So there are 9 technologies that have been sort of championed in the BCG document that became a central document in many of these discourses, and you can see that in front of you: autonomous robots, big data analytics, augmented reality, additive manufacturing, cloud, cybersecurity, industrial Internet of Things, integration at various levels, horizontal and vertical, and simulation. These are some of the technologies that are important for the story of Industry 4.0. And the expectation is the following, that if you look at this diagram, let me first show you the bottom. That's where you see all these technologies sitting there, IoT, artificial intelligence, robots, and so on. The expectation is that they are going to influence the 4 major functions that are smart functions: collection of data, exchange of data, storage of data, and analytics of data. And if that happens, then they can directly or indirectly influence quality, productivity, safety, and other key performance indicators, the KPIs. And then the expectation is that that will improve the value in product, the production, the supply chain, and the business, so as to improve competitiveness. So that's the story. That's the dream. Now, what is the reality? And particularly, I would like to talk about the micro, small, medium enterprises in India and its relationship to Industry 4.0. Now, why am I talking about micro, small, medium rather than big enterprises? Well, you see, India has about 60 million organizations that would be considered micro, small, or medium enterprises. And the reason why I'm talking about them is they are the backbones of jobs. Okay, they carry 33% of the output, manufacturing output, 45% of the exports, and 10 million jobs, 120 million workers. Now, if you compare the small medium enterprises in India with those in, let's say, Germany or Korea, it's very similar in terms of the output and the jobs, that they carry majority of the jobs in those countries as well. What is different, however, is that while only 20% of the GDP in India is carried by the MSMEs, the numbers are over 80% in Germany and Korea. So in other words, the MSMEs of the advanced countries have a much greater share of the gross domestic product. In other words, they are richer. And because they are richer, or we are poorer, our MSMEs are poorer, they have also lower productivity and efficiency. Now, one interesting observation here is that 90% of our MSMEs are actually micro organizations, nine or less number of employees. And what happens is that, and this has been already established by some of the OECD documents, is that if you have very small companies, then that implies low productivity. If the number can be increased, so say about 50, you will have at least 80 to 100% more productivity than if you have 9 or 10 people in the organization, because they have a larger mass and therefore they have a larger possibility of investment in skills, technology, processes, and innovation. So MSMEs and smart manufacturing, or Industry 4.0, if you will, the smart manufacturing technologies which are available right now are seen as highly capital intensive. And MSMEs don't see clear benefits, and they actually, in contrary, they see potential loss of jobs. Now, because of these, there is a low uptake of MSMEs. They are cash trapped, and this is capital intensive. So the maths are not really matching. So how do you improve this? Now let's understand the relationship between innovation, manufacturing, growth, and design. I'm putting up a slide, or I'm putting up a little diagram here. Again, it's not important that you are able to read it. I'm going to explain what it is. It's taken from what is called Global Innovation Index. Every year, Global Innovation Index a report is published in order to show how innovative each country is. And each dot here in this diagram on the left right corner, the top corner, is the output of one country. The y-axis is how well it is doing in innovation, innovation performance, and x-axis is innovation input. Roughly speaking, how much money you spend. So you can see that I can draw a graph, a kind of regression graph that shows that if you spend more money on innovation, you are going to get more innovation output. Well, that's not so difficult to imagine. But what is interesting is more than that. What you see here, this kind of cross that I have drawn here, the you see that for the same amount of money spent, roughly, different countries have achieved different amount of innovation output. That's the vertical patch shows. And the horizontal patch shows that same innovation output may be received by less amount of money or more amount of money. So there is more in the story than money. That's basically what it says. Okay. So, but broad message is that more innovation will, of course, be produced if you spend more on innovation. Second is that innovation leads to improvement in manufacturing, because innovation leads to new products, processes, and so on. And when you implement that, the life cycle of that comes in, and as a result, manufacturing gets expanded. The third is that innovation correlates with growth. That's the second graph that I'm showing on the right side, once again from the Global Innovation Index. And once again, let's not worry about the X and Y axis, but broadly speaking, one of these lines is R&D growth, the other is GDP growth, and R&D growth is a representative of innovation growth, and therefore innovation growth is correlating with GDP growth. So in other words, if you have more innovation in the country, then your GDP is also going to follow that. But the question remains still that how can we make our innovation more efficient? And that's where design comes in. Design is essential for innovation because it ensures that you are solving the right problem and you are solving it right, and you are doing that with the lowest possible investment, or in other words, efficiently. So let's focus a little bit more on innovation. So what is innovation? Innovation is essentially finding opportunity in the society, and let me just use a pointer. So finding opportunity in the society, and then finding means of fulfillment of the opportunities, and bring this back to the society. So it starts with society, it continues through society into another cycle, and so on. So that's the cycle of innovation. Now, what is involved in that? Well, there are different ways of sort of dividing this circle. This is one way, that in order to do this, you probably want to do it in multiple steps. You want to first identify the opportunity, then ideas to with which you can fulfill the opportunity, then implement that in products, and then realize them through production, and then make them available through supply chain, and make sure that the business works around it, that everybody in the supply chain is happy. Now, so these can also be seen as chasms or valleys of death. Are we getting the right opportunity to focus on? Are we looking at the most appropriate idea to fulfill it? Is this the most appropriate way of embodying this idea? Is this the most appropriate of producing this product? Is this the right supply chain, and is this the right business? So effectively, each of these can be areas in which one can go wrong. So just to give you a sense of what that means is that, let's say you have a half chance, 50% chance of succeeding in each case, then your overall chance, kind of joint probability, is going to be pretty low. And therefore, and it's not surprising that typical rate of success of innovation in India hovers around 4%. So people come to innovate with a lot of enthusiasm, a lot of energy, but only about 4% of them survive. In order to make the chances better, you need to do more than just getting people interested in innovation and jumping on the innovation bandwagon, but train them into doing innovation. And that's where design comes in. If we have a 95% chances of success in each stage, then of course we get a decent output. That's roughly the level at which IISc and my department CPDM operates. Now, going back to the opportunities for India's manufacturing excellence, these are some of the points that I want to make, that there are three broad issues. Of course, there are more. I'm just talking about three. One is that the current technology for Industry 4.0 is not affordable for MSMEs. So this is an opportunity for us. How do we improve this? Second is, as we said, they are low on technology catch-up, and currently they produce lots of jobs, but they are low on the GDP percentage. Second is that greater investment in innovation leads to greater innovation, but same input can lead to very different outputs. So once again, design can play a significant role there. And how do you make design innovation more efficient? There also design can play a role. Unsystematic innovation has low success rate. So these are my proposals or recommendations. One is that we have an opportunity to develop new Industry 4.0 technologies, and I call these advanced affordable. If you want to make something really affordable, let's say 10 times cheaper, and still provide the same kind of output, then this is not something that can be done by little optimization here and there, cutting corners. We need to look beyond what is currently available, look for new technologies, new ideas, new designs, and so on. So therefore, it has to be advanced. We need to look at the new horizons of technologies and bring them together. Make innovation efficient for the whole life cycle. This is where design-led, data-driven innovation comes in. And the third is make Industry 4.0 more inclusive, okay, and make the MSMEs themselves smart and innovative. Train them. Vivekananda said that it's good to give fish to people. I mean, this is of course in Bengali context. It's good to give fish to people, but it's better to give them an instrument with which fish can be caught, right? We can go one step further and say, train them how to design the instrument with which they can catch fish. And this is exactly what we need to do for the MSMEs. Can we train them to become design savvy, that they can design their own products and solutions and not simply meet the back end of other companies? And this is something we have started at IISc. So the overall point is that can we develop smart design, smart products, smart manufacturing systems, smart services, and smart businesses? So just going back to this innovation diagram, the innovation cycle diagram, if we look back at the 4 industrial revolutions, what was it that the UK was doing? UK was trying to make Industry 1.0. They were trying to make manufacturing more scalable by using machine power and rationalizing labor. Now, the journey from UK to Germany, they were trying to make manufacturing not only scalable using those, but also connecting industry to academia for better translation of ideas to production. Now, from Germany to UK, if you see the progress, they were trying to tap manufacturing innovation, so going all the way from opportunity to business for manufacturing. And what India can do is that it can support design-led, data-driven innovation for the entire life cycle. Tremendous opportunity. And I keep talking about design, and I must then talk a little bit about design itself. What is it that I mean by design? Because it means different things to different people. Now, at the core of design is something that you don't like. If you like everything, then you're not a designer. Some situation that is undesired. For instance, the fact that typical village folk women in India have to walk between 2 to 5 kilometers to the nearest water source for their daily chores of work. You might say that's undesired because it's a large distance away from home. You have to carry clothes which become heavier on the way back. You have to carry water back as well. There is safety issues. The roads to the water source are not particularly good. And washing is effort and time consuming, including the water sources get polluted as a result of using it or overusing it. So depending on what you think are the most important elements of undesirability, you want to then plan and what might the desired situation better be. Shall I bring the water back closer to the source? Shall we carry clothes on a way that's easier to carry? Shall we, and so on and so forth. Okay. And this is what you call goal. How do you translate from undesired to desired situation? And you plan, and that plan is what is called design. You hope that if you implement it right and utilize as intended, that undesired situation will transform into more desired situation. So a design is a plan for change. Okay, this is just an example of many possibilities. This is a village tricycle for women that is a recliner that uses the kind of muscle power that women have and give them a comfortable ride and also washing and so on, which is completely non-automatic and at the same level of quality as any existing washing machines. It's just one example, not necessarily the best one, just as an exemplar. So a design for a plan for change, It includes both the problem finding and the problem solving. So the dreaming up of what is undesired, what is desired, is also part of design. Okay, so here is a unique situation where as a student you get to also you design the question paper and also solve it. Okay, that's where design is different from a traditional discipline, that you not only solve somebody else's question paper, you also design your own question paper. Okay, so it's both finding the goals and meeting the goals and planning for that. And designing is how a design is developed. So both the goal and the plan is developed. So depending on who you are, if you are a designer of a technical system, which most of us are as engineers, then we'll be designing technical systems. If you are an educator, you might be designing an educational system like Maria Montessori. If you are an aesthetic designer, you might be designing logos. If you are a law designer, you will be designing legal systems, and similarly theories and models, including the models of sciences. They are essentially constructions with which we try to make the situation, the undesired situation being the undesired understanding, level of understanding that you want to improve. So how do you train somebody to become better designers? Well, our experience, we have been teaching design for 25 years now at IISc. Tells us that there are 4 areas that we need to pay attention to. One is that design cuts across the product, the production, the service, and business. So the innovation can take place in any of those places. And you need to have a mindset for innovation, which you might call design thinking, but also a more detailed process, structured process, that you need to go step by step in order to ensure that a complex product, especially, nothing is left out or forgotten, and that the resources are utilized in an orchestrated manner, that the overall process becomes efficient. Then underlying that, there are science and technology building blocks, and that includes not only the natural or engineering science and technology, but also aesthetic science and technology, usability, ergonomic science and technology, cost science and technology, and so on. So they are important to be embraced. And finally, there are tools and methods that can make many of these processes faster, cheaper, or easier, such as finite element analysis or life cycle assessment and so on, or brainstorming. They should be brought in. So it's a combination of these. Now, here are some examples of some of the work that our students and ex-students have been doing. This is Govind Sharma and Anup Chander, 2 ex-students from our Masters in Design program, who designed a diverter flip-flop. Okay, it's a chappal really, but the chappal ensures that the water doesn't splash back to the feet or the leg. And this is something that brought them the Red Dot Award, which is the Oscar of Design Awards, where 58 countries, 4,700 entries were there, and they were chosen as the best. This is a life-saving hypothermia alert. Mona Sharma, another ex-student, design head of a Bangalore-based startup, where they created a wristband that helps get babies get a better start. Essentially, it's a temperature monitoring bracelet that ensures that as soon as their temperature goes down below a certain value, that the caregivers get an alarm, and they need to be warmed up. And lots of babies die because of hypothermia, and they have been able to save about 10,000 babies from dying in 25 countries in 2017, which is why Time magazine picked this as one of the 25 best inventions of the world. The first racing bike, for those who are enthusiasts of bikes, would know that the first racing bikes TVS produced in 2017, RR 310, they also make the bikes for BMW. That is, this industrial design was done by, again, an ex-student, Arun Kumar Francis. It's called TVS Apache. You see Arun in the corner. Sickle Innovation is an innovation startup. 2 of the MDes students, Masters in Design students, Nitin Gupta and Nikhil Beshram, they decided to improve the cotton harvesting productivity of people in Western India, and came up with a handheld device that uses fluid mechanics in order to suck the cotton out of the pods, And they incubated that and got zillions of awards from Ministry of Agriculture and so on, and employing something like 25 people today. This is a prosthetic arm that is again advanced and affordable, that was created by Nilesh and Vinay. You see at the corner, bottom right corner. And what is the USP is this? And you see Mr. Eknathan, who is sitting on the top, sadly passed away last year in COVID. But earlier, you see this is the first prototype of a prosthetic arm that can hold an arbitrarily shaped object and wrap around it with just a single actuator. And roughly the cost of this product is proportional to the number of actuators. When you throw more actuators to it, you essentially increase the cost, but also increase the weight of this, which becomes far more non-ergonomic. And that was the USP of this product. So then later on, Wellcome Trust funded it to another 15 crores. Oxford University joined as a partner. And 5 years down the line, they have a company called Grass Bionics that has won the Elevate 2019 award of Government of Karnataka. And it's selling that product. Last couple of examples: an affordable advanced insulin pump for children won the Gandhian Young Technology Innovation Award from Deval Karia and Rohit Nambiar from the President of India. And then Ujjwal and Yogansh, a project called Clean Rat, which is a robotic sewage cleaner that won the Lexus Design Award 2019 in the open capacity. And an affordable inspection system for the MSMEs that won the Platinum Award for CII Most Innovative Low-Cost Automation. Essential idea, I'll come to that later on, explain. Finally, the affordable live organ carrier called Livebox that has won the James Dyson Award in 2021 and Lexus Design Award in 2022. So all of these have been innovated. So what is it that we have been doing? Well, what we have been doing is that we have been training our students in systematic design process, in all the elements that are important that I showed you earlier in the innovation matrix. And we are also giving them an opportunity to do startups and so on. So my department, Center for Product Design and Manufacturing at IISc, is the design and manufacturing phase of the institute. We are among the top design schools. If you look at just teaching, this is what QS rankings give, but also if you look at the number of high impact researchers in the department, then it's the first top in Asia. This is IISc. I think I will not belabor the point, but it's the best university in the country and one of the top in the world. What do we do at CPDM? Well, we pursue excellence in design and manufacturing so that we can support development of systemically complex, technologically intensive, and socially impactful solutions. I'm sorry, I need to turn off my, just 1 second. Okay, I just shut it off. And in order to do that, it is important, of course, to be functional, right? And that's what we primarily train in engineering. But it is not good enough to be just functional. It needs to be aesthetic, it needs to be usable, and it needs to be sustainable. 99% of the prosthetic arms are not used, not because they are not functional. Oh, many of them are not. But a major reason is that they are not usable. So we focus on hardware-centric prototypes. We have 2 programs, an MTech in smart manufacturing, which started only 3 years ago, and an MDes in product design and engineering that has been going on for a quarter of a century. And of course, we have research in both areas. I will now spend a little bit of time about some of the innovations that we have been doing as part of a smart factory initiative at IISc. It's a common engineering facilities center, or CFC, that is funded by Department of Heavy Industries. And 20% of the money comes from industry, such as Toyota, Tata Consultancy Services, and so on. And 80% money from the government to create a platform around which manufacturing innovation, smart manufacturing innovation can happen. So the key question that we asked is the following, that our kind of factories are not only highly automated, factories, and automation is important, but not as important as ensuring that people are empowered. So therefore, we need to really look at a different paradigm of smart than what is currently being championed in the West. So the question that you asked is the following: how can you use smart elements to empower not just, you know, factory in terms of greater productivity, quality, etc., using automation, but also how do you empower human labor? So we are creating two platforms. One is a automation intensive one, and the other is a human intensive one. Because if you look at the factories that India has, a majority of the factories are a combination of these two, and the majority within that are largely just human labor intensive factories. So if you look at these cartoons here, what you see is a typical factory where you have an incoming storage and inspection and outgoing storage inspection, and a number of data intensive machines that do transformation of materials, and some materials movement activity in yellows and so on. The difference between these two platforms is that in one case, everything is the manual legacy machines are used for transformation. Humans or manual cranes are used for movement. In the other case, it is data intensive machines like a additive manufacturing machine or a CNC machine and so on. And the movements are happening using AGVs, automated guided vehicles, robots, collaborative robots, and so on. The only distinction is that these blue lines you see here, which means that they are connected, and they are connected whereby data is getting stored and analytics can be performed. And we want to see how these two make a difference, okay, in terms of the KPIs such as quality, safety, productivity, and resources. Okay, and about 2 years ago, just before COVID outbreak came in, it got started, initiated by the SHI, the Secretary of Heavy Industries. You see the digital twin on the top and a combination of automated guided vehicle and a collaborative robot. But these are some of the projects. Okay, how do we assess the worker safety in real time? How do we track the assets, particularly non-expensive assets, in an affordable manner? How can we acquire knowledge from documents, legacy documents, and use in manufacturing automatically? How can we make legacy machines smart? How can we make MSMEs more certification worthy by collecting data and telling them where they have problems with being certified, like ISO? How do you use smart in order to make manufacturing more sustainable and reduce, say, environmental footprint? Or how do you develop robots that interact with each other much like we do right now with each other, right? We speak and we make gestures, we make eye contact, and we speak, right? We don't type stuff. So I'll show you some examples. This is a smart solution that came from a company called Vinyas, okay? Did not came, the problem came from them. They had these workers who were putting together printed circuit boards, and they were making mistakes, right? And what we did was we brought in imaging technology, yeah, and laser in order to guide them through the process and ensure and tell them where they were getting wrong and so on in order to increase productivity. This is a smart resource bin, right? Each resource bin knows what is it that it's collecting as waste and how much of it is getting collected. So you can have an army of those resource bins that can talk to each other and tell us how waste is getting generated on a factory floor, and you know, that gives you an idea of how to utilize them. We have implemented that, by the way, in a micro factory, and they will break even within a year by simply saving on the waste. This is a smart inspection solution. Micro manufacturing company, they are making shoes, and they have these sheets of materials that come in, and there are small defects in them, and workers often miss some of those defects. They go into the production line, and they lead to both wastage of material, time, and cost. So we created an image-based solution whereby we can stitch together the images and figure out where the defects are and point the workers to them to take care of those. The key here, it is advanced affordable. The key here is to look at where the cost is and shift the cost. For example, here the cost is in hardware, right? Expensive cameras is the major areas where the cost is. We changed that. We took some inexpensive cameras, we took lower quality photographs, and we improved the quality of image processing in the algorithm. So by moving it from hardware to software, we could then bring down the cost. Again, it's a 10x product, 10 times cheaper than what is available in the market. This is a multimodal robot. This robot, it can be instructed by eye gaze or by hand waving and so on, and it will go and do the stuff that you want it to do. So this is already patented. This is another one where we are trying to explore if we can create a single machine where we can, for example, print a complete watch like an electronic watch. So it's a combination of polymer additive manufacturing, where the casings will be made using polymer, metal additive manufacturing to create electrical channels that connect the electrical components with each other, and robots that can put together the individual electrical components or electronic components. And so it's a hybrid additive manufacturing for embedded systems. So we have a advanced manufacturing program with around the Smart Factory initiative, where we take R&D projects for large companies like Forestia, Yaskawa, TCS, and so on, and also provide training to companies like HAL, Ashok Leyland, and DRDO, and do innovation projects with MSMEs, as well as doing awareness programs for PSUs and so on. And there are some of the areas, right? Additive manufacturing, digital manufacturing, robotics, augmented reality, design thinking, and so on. The MTech in smart manufacturing operates with a multidisciplinary course. So if any of these undergrads are interested in doing an MTech, then this is something to look at. Advanced materials manufacturing processes, courses in those, but also digital design, HCI, human-computer interaction, and so on, as well as system sensors, AI, and supply chain and entrepreneurship, and then hands-on skills and training, and finally, of course, research and development projects. The MDES program in design and manufacturing has a similar flavor, but the focus is on design, so we want to create future leaders in design. Once again, multidisciplinary courses which has materials manufacturing, you need to know that for designing your product, but also design thinking, ergonomics, human-computer interaction, system sensors, analytics, supply chain, and then using hands-on internships and projects. And products is particularly important here. These are all no research projects. These are all design and development projects. They have to identify a problem from society and they develop a working solution for that. That's what they need to do. These are some of the people who are involved. We have 11 faculty from 11 departments involved in the manufacturing program and design program. And we run also 2 research conferences, one in design called ICORD. The 9th one is just about to happen next year. The call for papers is right now on. And also it is relevant right now. It's design in the era of Industry 4.0. This is in next year, January 2023. And we just finished in the second international conference on Industry 4.0 and advanced manufacturing. All these proceedings are published by Springer and indexed in Scopus and so on. The messages for the talk are the following. One is that Industry 4.0 is about connected intelligence. And it is not only about automation, it's about autonomy. How to bring people, product, process, tools, environment together in order to improve the performance in terms of all the KPIs. Second is, as I said, I've already covered that all these 5 elements are important. Design innovation is the key. And this is just a link to Smart Manufacturing Initiative IISc. And I would like to thank you for your attention. If there are questions, I would be happy to try and answer them. Thank you.
Thank you, Professor Chakrabarti, for your enlightening lecture. The session is now open for discussion. So questions from the audience, please.
Sanjoy, Ochut here. Hello.
Yes, please.
Can you hear me?
Yeah.
Yes. Can I say something?
Yes, please.
I heard the lecture. To me, it's a dream kind of lecture, dream kind. But it's a difficult lecture. not for ordinary layman. Typical concepts has been introduced beautifully in a cadence way in this lecture. So I must thank Professor Amaresh Chakrabarti. I enjoyed the lecture. But I like to tell one thing, that is it to build up an infant of an animal like a deer or a crocodile, you don't need much of a training. But to build up a human infant, lot of training period is required, 20 years. So, but still that is incomplete. So, industry heard from Dr. Professor Chakrabarti, the gestation period is rather high. And I don't know, he didn't talk about the intellectual level of the participants. I think that requirement will also be rather high. But I must say, I am indebted to Professor Chakrabarti that I attended this lecture, and my learning, and that these things are happening in my country. That is the most important thing. And I'm delighted and I'm proud of Professor Amaresh Chakrabarti. Thank you.
Thank you, sir. Thank you. Yeah, let me comment on the point that you have raised, that what is the intellectual level that is necessary. I think it's an important question. And gestation period for any serious technology is going to be high. There is no doubt about it, but we must start somewhere. And I mentioned very briefly in the beginning, I did not elaborate on the point that among the several enablers for this, one I mentioned is that we need to provide long-term support for development of these technologies. And let me share a story with you. One of my visits to Hannover Messe. Hannover Messe is one of the largest industrial fairs in the world, where it's a feast of eyes for those who love manufacturing. You can see capital goods from entire world sort of showing up there. So in Hannover Messe, it's very easy to get impressed by the great machines that are created by Stumpf or Makino or uh, DMG Mori and so on. But I spent a great deal of time in small booths that were from the German universities. The reason is the following, that when you see the machines that are just about there for selling, you know that these technologies are already old. But if you go to the university booths and see what is it that they are thinking, you know that they are thinking 10 years ahead of their time. And you can see what technologies they are thinking about that are going to come into those machines 10 years down the line. And we need to create our universities powerhouses for those advanced thinking. They should tinker with that. And I think we need to create the test bed and fearless students who can tinker with that in each of our universities. They should thrive, they should enjoy tinkering with new technologies. That's what we need to create, our engineering universities. Not sort of try and optimize somebody else's idea. And that requires large investment in time and patience. Patience is important. Nothing worthwhile gets done just overnight. And we need to do that. 10 years down, we'll see. There will be lower hanging fruits. There will be fruits that are higher. Some will come earlier, some will come later. Many of them will fail. We need to train them in failing and learning from the failures, because that's the only way to learn.
Professor Ghosh.
Thank you, Professor Chakrabarti. This is Kamal Sarkar. I'm 68 batch mechanical. Thank you so much. It's really very enlightening lecture, as Ochida said. Let me tell you, let me give you a slightly different perspective. I'm from USA. I teach in the University of Texas. In this country, we have got what we call I-Core. Basically, it's a shortening name of Innovation Corporation. And basically what NSF, National Science Foundation, our basically the award-giving staff for the universities, they were telling us about 10 years, up to 10 years back, they were spending literally, not spending, they're spending hundreds of billions of dollars. The question at NSF came up, what the heck we are getting out of all these hundreds of billions of dollars from the universities? They found out their rate of return is not even 10%. So that really means hundreds of billions of dollars going down that drain. The question is how can change the scenario. So then they came up with the idea, okay, we'll not just give the money for any innovative thing from big schools, MIT, Harvard, or Princeton. We'll give the money only to those guys whose products are marketable. As you rightly said, and let me make sure we are on the same page, there's some semantic issue. What you are using here as design, we use something different. We call it disruptive innovation, when the whole thing will change. The question then came, rather than starting from up researcher and then try to find it out what the application, they start other around. They asked everybody, give us the idea. And where's the market? Is there a customer for it? As you rightly said, even in this country, 80% of the ideas go down the drain. It doesn't make any money because customers don't want. 80% of the product done by the research in university, nobody wants it. Only 20% come back. The question is how we do it. So what they did, other around, they come up with idea, and we do not worry about the innovation or validity or research area. Find it out who is the customer. Is there anybody there who wants the part? If that is the case, then we'll see whether you can solve the problem. Their approach is that if there's a real need, there will be innovation. Okay, so they don't worry about that part. And that way they do all across the country. We have got so-called nodes. Actually, there are about 60 nodes all across the country of US, and all those nodes, like basically spoke, they get ideas. Each node gets hundreds of ideas. Then they start selecting. Then once their region is they are selected, then from the region they go to the national. That's the process. And they found out that rate of return is significantly higher. It has more than doubled. Okay. Now, I participated in one of them, and I went all the way to the national, and it was given, and that money they don't worry about. The key part is that, and that's the part I'm trying to emphasize, is that unlike university researcher, during the discussion, they don't even ask, how do you prove it? How can we do it? They only ask, do you have a customer? They give money just to find out who are the customer and what they want, is the product available, affordable, and then they find it out. So coming back to your point, you are really right in the sense that Industry 4.0 is same thing. How to connect the customer with the researcher, how we do it. And if we can do it, then if he cannot do it, I cannot do it, there will be somebody else who will do it. Because the market is identified, need is identified, and then the process will be developed, depending upon what is the need. And that's the way it is. So even if there's a semantic issue, but in general, your lecture is very, very interesting. Only one comment I'll make is that I did not hear anything about deliverability. The question is that I have a wonderful product. Okay, customer needs it. How I deliver it? This COVID-19 has told us one thing, that all the Chinese product the cheapest, best, etc., whatever you want to say, is all over the world. Now, because of COVID-19, the whole supply chain has been disrupted. So the question is that how robust the system is. And this is where 4.1, in my mind, has a huge value, so-called distributed manufacturing. That will be one point I was trying to find out. Because if the delivery is not there, we know it, I know it now, we are willing to pay more. I want something, I don't get it. Then it comes 3 days later, inferior product. How that can be addressed, and I'm sure you have looked into it, but that is one area of interest: deliverability, supply chain, distributed manufacturing. That's the part, But I want some feedback from on that area.
Okay, thank you very much. Again, I appreciate your comment. So I'm going to comment on 2 points. One point is about this very interesting initiative that you spoke about from NSF, about finding the marketability of the idea. I think it's a very important approach, but it should not be the only thing that academics should do. It is very dangerous to do only today's need-based research, because then you shoot yourself in the foot for what's going to happen 10 years, 100 years. Let me share a story. Okay, it is an important story, and I find that quite instructive. And the story is the following: that a few 100 years ago, a bunch of mathematicians, as mathematicians often are, got interested in figuring out whether they could cross 7 bridges in a place called Königsberg in Europe without having to recross any of the and come back to the same original point. Okay, I mean, and of course, a lot of people did a lot of walking back and forth and never managed to do that. But of course, that's not a proof. That simply says that out of whatever possibilities are there, you may have explored less number of possibilities. So that's not a proof. Mathematicians would not have found that an interesting example. So eventually came a guy, he said, well, let's simplify the problem. Okay, let's say that each island is a node and each bridge is a link between the nodes. And if I do that, then I can create something called a graph. And then once I have a graph with n nodes and whatever number of connections, links, I can find properties of those graphs and tell all kinds of things, including whether I can start from point A and come back to point A again by crossing each link or traversing, as you would call it today, only once. And yeah, as one part of that generalized problem, it turned out that the number of n and the number of links and nodes were such that in this particular case, it is impossible. But that opened up an area called graph theory. Okay, and absolutely no application, except of course if you want to figure out whether those 7 bridges can be crossed only once and you could come back to the same place. But then today, the fact that we are talking to each other is because of graph theory, among others. The fact that you are traveling on a train, and as you seamlessly speak to your friend, this mobile phone is trying to find out the nearest possible towers. That makes it the least cost communication and seamlessly move from one tower to the other, all again because of graph theory. Now imagine if NSF were there that day and did not fund Leonhard Euler to spend the money or the effort on graph theory, what we would be today. So it is important that we have money spent on all kinds of research. And I'm not demeaning the effort, but certainly it needs to be more inclusive than that. Coming back to the distributed supply chain, I did mention it, but I did not elaborate that. I said smart products, smart businesses, smart supply chains, and smart productions. And distributed manufacturing or distributed supply chain is of course an important area, which is one of the possible smart supply chains. And I know, I'm aware of the large amount of work that is happening in that area. Saundar Kumara, for example, at Penn State, is doing some substantial work in that area in your country. So yes, important comments. Thank you. I appreciate that.
Just a correction on my part is that obviously I don't represent US. You understand that. It is what I was trying to say is that how NSF changes approach. And obviously you are absolutely right. There are tons of other organizations in this country, they fund that type of stuff. But NSF changed the role because of that. But there are NIH, Department of Defense, Transportation, there are tons of, obviously you understand, they are spending it on. But you are absolutely right.
Thank you.
Professor Mullik.
Well, I came to this platform to talk only once. All other days I come to listen. And every day it is being told by an expert. And there is, except saying that is a grand lecture, but it's supposed to be grand. I'm not surprised. So why should I say that Amaresh gave me a lecture where I learned a lot? Thank you.
Thank you, sir.
Ghosh. Professor Ghosh, any comments?
You want me to
Professor
comments is
Amitabh Ghosh, please.
yeah, Amitabh is there. Oh,
He
I'm
was
glad
there.
to hear him.
He was there.
There is there. There was there.
Professor Ghosh
Perhaps
is not
just
there.
left on.
I just have one
is there?
comment to Professor Chakrabarti. Yes, we all are in academics and we are doing research, sometimes need-based, sometimes basic research. But particularly if we think about the manufacturing sector, in the last few decades, the Indian focus on manufacturing sector has been minimal, unfortunately. Okay. Most of the things, even if you consider Tata's big industry houses, I can talk about refrigerators and air conditioners, Blue Star, Tata, they all are coming from China, Korea, whatever, or Japan. And they are just put stamps. So how this mentality can be changed? Because we like to produce managers rather than engineers, unfortunately.
Okay, thank you for your comment. See, at the end of the day, the companies are not stupid. Okay, if they're doing what they're doing, then it makes sense that that's why they're doing it. So question is, why are they doing it? The reason why they're doing it is because they are not competitive in a cost sense.
Yes.
And the reason why they are not competitive is because their market is limited. If you look at the German MSMEs, well, they don't have M, that's first M. They have SMEs or Mittelstands as they call them. Many of them are MNCs. Stedler, for example. And as you said, the Chinese goods are in the market and so on. And that's partly because we are not able to compete with them. Their market is much larger. So one incentive, this is not just incentive, but also training that we need to give to our MSMEs is how do you capture global market and not just the Indian market or the portion. And there are two portions.
Indian market is not also very small, isn't it?
It's not also very small, but when you look
and
at
we had quality products, isn't it?
We had quality products, but this kind of competition
we are not inclined to upgrade. That's the problem.
I will answer Professor Sanjay Gupta. Kindly, Amaresh, kindly permit me. You see,
The market is getting different.
Bajaj scooters and motorcycles, they have taken the African market. There earlier it was the Chinese product, and now Bajaj has thrown away the Chinese people from that market, and they are doing it with Indian ingenuity and Indian engineering. That input I am putting here, but I may put further inputs as and when as the discussion goes on. Thank you.
So let me just complete that. Thank you very much, Achyuta, for your comment. I think we need to look at it in this way, right? So if you look at what is, let's say, what is value, right? And I'll simplify it. Okay, value is performance by price, right? you improve some kind of ratio, right? So something can be very inexpensive and high quality in the sense that, sorry, high value in the sense that there is a market for which it caters and it does the best in doing that. And there is another market where it is the high-end market where people are ready to pay more, but they also expect more, right? So your value may remain the same, but your denominator and numerator goes up. Now, if you look at the Indian car market as opposed to, let's say, cheaper goods market, right? Indian car market is still very largely dominated. I would not say dominated, but there are many players, Indian players, that are quite competitive in that sector. But if you look at the much cheaper products, they are not. Similarly, if you look at um, refrigerators, refrigerator market, you would know it very well, right? It's not only the cheaper products, it's also more expensive products where the Chinese are doing very well. See, over a period of time, when you become the manufacturer of the world, your technology competence continues to grow. And you can utilize that technology competence and bring it across to other places. It's about good quality people. So that's what I was trying to say, that we need to empower our MSMEs and universities in turn in doing two things at the same time. One, being open to capturing a larger market, and number two, training them well, and training them not only in supplying a part to somebody but also designing and developing parts of their own, because you get a much greater chunk of the value if you are able to design. Otherwise you get a small value. See, if I sell just the material, I get a certain value. If I turn it into a piece of steel, I get a bigger value. If I turn that piece of metal into a product, I get a far greater value. So you are losing on that value by putting the same amount of effort. And that is where going up the value chain matters, and the training that is necessary, and the confidence and the support that is necessary matters. We need to build that ecosystem so that that happens.
Yeah, but the big industry houses needs more participation in the whole program rather than the MSMEs, because they have more funds with them, isn't it? As like Bajaj, Tata, or other things, they can afford to do some research and innovation. How can we expect a small MSME to come and do research?
We don't.
We can't.
We don't, but none of these are going to happen by philanthropy. This is something that they need to see the benefit from. And right now they are comfortable doing what they are doing. Unless they have a much bigger plan, they will not do it. See, we are already working, I'm sure you are too, with some of these companies. For example, Yaskawa, which is a robot manufacturing company, they are getting their um, um, imitation learning algorithm designed by us. Because if they put that, their robot becomes more efficient. So that company understands the importance of it. Tata Consultancy Services, that is also a Tata company, by the way. Tata Consultancy Services is doing about 2 crore worth of research every year with us, where they are developing products, smart products, that are going out to industry. So it is happening. It's not that it is not happening.
I'll add my 1-2 bit here. You see, Mr. Edison, he once said that you make a new mousetrap, people will line at your door. That new mousetrap concept is not concerned with it is MSME or MSC or large or small. I have put in my 2 bit here.
Okay.
Actually, general for comment is that I don't believe innovation is a servant of big corporations. Innovation is almost an equal opportunity employer. Innovation can be anywhere. And the problem is that not that innovation is, there's a dearth of innovation. The problem is there are two issues. Number one, in bigger countries, they have the opportunity to find them. There are resources, communication. In countries like India, there's developing countries, those where mostly goes wayside. That is one issue. Second issue is that even if we find the innovation, the challenge is that how you nurture it. As I say to everybody, even diamond has to be cut. A rose has to be fertilized, maintained. So this is another issue. That depends on the things happened in other countries, like even what the China did. Think about it. Within 5 decades, they dominated the whole market, the whole world market. And that is good and bad. And that is my perspective, is that this is not fair, because Chinese did a lot of stuff, a lot of people didn't like it. But that's a different issue for a different day. I'm not getting into politics. I'm talking about it in general. This is where probably Industry 4.0 will open the door for India. The thing is that Chinese product comes, whether it goes for Australia or USA or India, they are the same manufacturer, same idea, same. There's no local stamp. With distributed manufacturing, India can be a player. India can supply a lot of stuff. But the question is that how we prepare ourselves. That is what the Professor Chakrabarti's thesis was. And he's using the word, design, but we prefer the word innovation, that part. But the same thing. It's a semantic issue. But question is that university has a role to play to make our students ready that what is coming. As I told the other day, 70% of the jobs does not exist today for the babies to born today. Our job is to train them, make the environment ready. But if we can do it, I think 4.0 will break the door for India, and it will be equally powerful as China anytime. But it may take a couple of decades, but I think that is coming. That's at least my dream.
I hope so, but in educational institutes, the students are reluctant to go in technical jobs. That's the fact. 90% goes to business analytics.
Let me tell you that part. Let me tell you that part. It is true for everybody. My dad said the same thing. This generation is going to hell with musket. Same thing Socrates said. Same thing will be telling. Same thing in India. Same thing in USA. But not true. Okay. Just have some faith, as I read. I'm sure some of the students will listen. Not all. It's a Gaussian distribution. Some of them will not listen. It doesn't matter how hard you try. Some of them will definitely be. But that's my observation.
Professor Mollik wanted to say something. Yeah.
This is nothing serious. I just wanted to continue with Professor what Dr. Achyuta said. That when we were just graduating, a lot of our friends joined CMERI, Durgapur, and we asked them, "What are you designing?" He said, "An improved mouse trap." I asked, "Are they catching mice?" Well, no, the mouse is not improved enough yet.
Anyway, I think the government needs to pay attention. There should be proper planning. In mentality, that's overall it is necessary. Otherwise, all the efforts, the training, the manpower, it all goes into the drains. Okay,
actually, when a nation improves, it has to improve in all fields. You cannot say only technology will improve and rest of the things will go down the drain. This one has to realize the society can improve as a whole.
I must
the basic education also must improve if your industry has to improve.
Ashok, I'll tell you, the fundamental researches are continuing to be done, has to be done. As our Professor Sri Amaresh suggested, that the fundamental research work which is not applied, which will lead to applied after maybe down the lane 30 years, 40 years or 50 years. Unless we go on in doing the fundamental work, then we'll dry up. So our country today has given focus to applied researches all, but fundamental research I think is being very much neglected, which is not appreciated.
I can just share a brief experience. I work in the field of biomechanics and orthopedic implants. there has been, in last 16 years I am here. Before that I was in Imperial College London. I did my PhD from Delft. But one or two companies from Gujarat, they came with some hip implants, and they wanted me to certify that it is the best in the world. Okay, I said, well, I cannot do that, otherwise I lose my job. Okay, as simple as that. Okay, so there is always this shortcut and copying a rejected design and putting it in the market. Be it an orthopedic implant going inside the human body, or it's the same, that they consider it as same that goes into the wood, and a screw going into the wood, a screw going into the human bone is treated as the same.
That's scary.
I have got reports.
Between nail and screw.
Yes.
For a lot of our technicians, there is hardly any difference between a screw and a nail. I've seen they just hammer the screws.
Yes, and the doctors, top orthopedic surgeons, I have received reports that these things are rampantly used. The screws, which should go inside a wooden furniture, has gone inside human body.
That's scary.
Yeah, because there is no regulatory board to control things.
But still we go on increasing our number. Nothing can kill us, really.
Yeah. So where there is a advanced manufacturing sort of setup here in IIT Kharagpur, and I was talking to Professor Surya Pal, and we are trying to organize so that big industry house like Tata can come into this whole manufacturing of orthopedic implants, because there's a huge market. There's a huge market.
Absolutely.
But 16 years I am here, there has been no interest about it.
From industry.
UK takes the output of my research, and I know very well they have got many projects allied with the industry in UK, Smith and Nephew. Yeah. And I gladly give them my sort of research outputs.
There are two fields in this country which is crying for new business house to take up. One is this implants, which could be in 10,000 crores industry. Everything is imported. And the second one is, unfortunately for a country like us, we do not have a foundry. This computer foundry. I mean, this computer foundry, yes. Chip making foundry. The chip making foundry, we are dependent on the world, which is, and today's, if you look at the world, how war and other things stop deliveries of things to a particular country. Here we are lagging very much. I wish some of our very large companies come up in a chip foundry, and some large companies with quality control, they come up in the medical implants. Thank you.
So I'll just make two comments here. One is about just for the audience, because it may lead to misunderstanding. I beg to differ, Professor Sarkar. When I use the word design, I don't mean disruptive innovation. Okay, I mean a discipline called design that trains in systematic innovation using a corpus of knowledge that is typically not used in traditional engineering innovation. Okay, so it is not just doing innovation. It is doing systematic innovation using a bunch of processes such as design methodology, the tools and techniques around them, and properly trained in ergonomics, in aesthetics, in cost engineering, and so on. So it's not just disruptive innovation. So there is a bigger difference than just semantics. And second is, I of course sympathize with Professor Gupta's point. I mean, about the frustration one may have of students going to do banking and so on after engineering. But we must also be realistic in our expectations. that a major reason why people come to any professional training is to get a decent job. And some of these banking and other sectors pay a lot more than technical sectors do. So the question is, if somebody has come and primarily for getting a good job, then this is an opportunity that is way better in terms of money than others, then clearly they will go. The economics should decide. So the question that we need to ask, of course, we can ask the government to support us and all that. And of course, that is a given. We should. But we should also reflect back on ourselves to say, what is it that we are not doing, which is why those who came to do technology are not getting interested in technology development. And I think this is something that is also an opportunity for us to self-reflect.
Yeah,
I feel that
it's a bit of a chicken and egg problem.
So Professor Gupta, let me just make the statement, and then you are the co-host, so you can speak. So what we need to say is that how do we make technology development interesting? Okay, and I have myself studied extensively, lives of innovators like James Watt, Isambard Kingdom, Brunel. You have been in Imperial, so you know the name of Brunel. The first transatlantic steamship was designed by him. The first pneumatic train system was designed by him. Ahead of its time, didn't get accepted. Avon Gorge Bridge was designed by him, and so on. James Watt, of course, you all know. And then a whole lot of other people, Leonardo and so on. And one thing that I found common, and there are 10 traits, but I'm not going to talk about it. One thing that is common across all of them is that they are all internally motivated. They are all self-motivated. Where did that self-motivation come from? The self-motivation come from the excitement and fun of doing engineering. Okay, the fun of solving problems that can make difference in lives. Okay? And this is what we need to inculcate in engineering institutions. Our teaching, our training should be such that we are not, pushing a whole bunch of technology that is already figured out by others. But how do you invent technology? We should train them in that. Once again, I come back and say, please create a design department. Please provide design training to your students. And you will see that they will, at least some of them will fall in love with that. And anyway, even 10% is good enough.
Yeah.
They
Come
will
back to the
transform.
point of curriculum development.
Absolutely. It is very important. The way we teach engineering, I'm sure you do much better job than we do perhaps at IISc. But, it's not good enough to simply, tell them what has been done, lots and lots of that. We need to give them the excitement of inventing knowledge. And most of them don't get that. So I think we need to create opportunities where they can do that.
And we also do not know how to infuse it.
Sorry, I didn't get that.
Professor Chakrabarti,
I think we also
I-
perhaps know how to infuse that enthusiasm into the students.
Yes. We need to do that.
Mr. Chakrabarti, I like to add one item. You just mentioned Leonardo casually, but to my mind, if I consider the three most brilliant human beings on the face of the earth, Leonardo, Einstein, and Rabindranath Tagore. That is my assessment. Leonardo da Vinci is so high up in my scale of thoughts. Just this is aside.
Absolutely. I cannot agree more, Uchuddan. Exactly. These are the three people. They are three gods to me. They are three murti. They are three murti for me.
Well, I leave that debate to be done separately.
Okay, just I just wanted to continue with the last remark. See, for example, if we take...
I will take a point from the chair in the...
Just a moment, let me finish. Yeah, hello?
Yes.
Yeah, please go ahead.
Yeah, so we had organizations like ISRO when we were sort of very young. It was not a company or sort of organization which was very sought after. But look at ISRO now. It takes time to develop. Okay, we have the railway research facility here in IIT Kharagpur. Well, people are giving time, some funding. It requires funding to develop the indigenous technologies, and it is bearing fruits. So that attitude of the government or the big industry houses has to come. They have to come forward to take the knowledge from the universities and institutes. I would put it that way. Rather, industry institutes cannot be an extension center of industrial houses.
I agree. It should not be.
The mentality has to be improved. Like, as I told you about a company coming to me and approaching a certificate from Gujarat, if that is the mentality, we will copy and manufacture and sell a rejected design. Nothing will improve like that. We had one time Kawasaki Bajaj. Okay, so that was a rejected design from Kawasaki, and India is to copy that. Bajaj developed this Pulsar with the help of Professor Muljal's contribution from IISc. It is selling like hotcake. So if we always try to copy things and don't try to develop something through really in-depth research, we cannot develop new products or sort of products which are...
Professor Gupta, the picture is like this. For a company, they want to go by a proven path. They want to get some money first. They want to earn some money. They want to establish the product, then go on improving on that. That may be the approach. That may be the approach. Thank you.
Yeah, but institute universities cannot be an extension center of the companies.
You are right. I agree with you. The industry can use it once in a while as an extension of their R&D part, but university must have its own life. They must have the ability to do something more.
See, I was informed by a professor from Delft University that TCS and these companies are taking up analysis of orthopedic implants and generating some rubbish results. And in the Europe, he was taken as consultant to check those results. And he said, this is pure rubbish. Because some people, they take 10 pounds or 10 euros or 15 euros per hour to generate a finite element model and analysis, and it is full of rubbish. So garbage in goes, garbage out comes out. So you see, if you try to do cheap things like that, if you try to make profit by giving the least priority to the heart of the analysis, then those things will happen. And the companies in Europe, they are not fools. They always put a question mark to whatever is coming out of India, China. Even we face it when we put a paper from India or same paper from United States or Europe, it is given a different status. Everybody knows about it.
Sir, may I say one thing? I may
Yes.
be very insignificant in talking about this thing because I have not done any significant till my research. So basically, sir, on the West and all we are saying what them as the leaders and the innovator that is developed country, where they have developed this arch, the aspiration to be in the top. Okay, so that is why they are in giving input to the research and all those, that mentality is driven to that. But in India, we are not into that. We are not want to become the world leader like this. So if you don't want to become world leaders, then basically we are middle class and we are doing same way. We are doing cheap things. So our mentality is not such that we want to become world leaders. So we have to become, so that mentality should be inculcated first. So just few decades back, the industry that and the companies, so the businessmen are not looked into a good sense. Okay, only the educators and all those things, that jobs are basically noble jobs, but the businessmen are not noble. So if that is the mentality, then they will do something in that way, that what they are doing. But we have to make them that they are also good people, they are also great men. So
if we don't inculcate that, then how can we be like that world leaders? Because sir, Acharya Prafulla Chandra Ray was a great chemist, but he was also a great inventor. At that time there was Edison and we have Acharya Prafulla Chandra Ray, but that part of the Acharya Prafulla Chandra Ray was not taken care. That entrepreneurship, that is why that his company is going down, and that part is not inculcated in Bengal itself also. So that is my. So I have understood. I have just want to share these things basically.
Okay, thank you. Nice to hear from the students.
Thank you very much.
No,
Mr.
Okay.
Biman Ghosh
he is
also
a
raised
young
hand.
teacher of
Okay, oh, sorry. Shantanu Das. Okay, I did not see
Shantanu
any
is a
prof.
young teacher, joined a couple of years back.
I am student actually. Basically, I am teaching, but I have just become a teacher. But I'm still a student. I am.
No, I recognize you because because Shantanu Das is such a common name like Sanjay Gupta. Huh. So now I
We are all
recognize you.
students. We are all
Yeah,
students.
and I recognize you. I think you
We all
also
are
have,
learning.
you were selected in IIT Kharagpur as well, isn't it? As I can rightly remember.
No, sir, I have not applied for there. So for what purpose you said?
Maybe as a postdoctoral fellow, something
Yes,
like
yes,
that.
yes. Under
Yeah,
Professor Anirban Das.
yeah, Professor
I was
Anirban
there
Das.
for 1 month. Then I got a job in IIST, so I came back.
Yes, I know you. I know you.
Mr.
You
Biman
were-
Ghosh has raised hand.
Yes.
Amaresh,
Biman,
this is Bimanda, HQ metallurgy. Our journey goes back from the oval to your IISc these days. Just
Absolutely.
congratulate you on your journey.
nice to get to Biman here.
Thank you very much for stimulating this discussion. I know this discussion involves a lot of philosophical spaces, economic aspects, political consideration. But we as scientists, engineers, technocrats, whatever we can generally provide the broader landscape, inspire students to come into the aspects of innovation. And I just request for future lectures that to think about paths, how we can stimulate discussions amongst the students. Like if even through all of the centenary lecture, we can inspire one student to be an entrepreneur, an innovator, well, that's probably the best thing that we can get out of the centenary celebration of our mechanical engineering department. And just for our senior members, eminent panelists and everybody, there are things that, of course, technology itself is driven by the economic considerations. Like think about these FANG companies like the Facebooks, the Amazons and all that. 20 years ago, they were not existing, right? So it's the market economics that decide that where the technological path is going to be chosen, as very rightly pointed out by Amaresh. Students like probably 10% are retained in the core engineering sectors. 60-80% goes in the service sector, and whatever profession they're getting into to earn a decent living, they're going to go there. So
Biman,
it's
I like to see your face. Biman, I like
Uchuda,
to see your face.
Uchuda, just let me finish, please.
Okay.
So what I would suggest that, yes, the discussions that we have had, Kawasaki's loss design, Pulsar came in, etc. But the Kawasaki Bajaj still made a boatload of money. So the point is, the economic consideration for an industrialist, for an entrepreneur, for an investor is not the same as Amaresh or other people are thinking about. We talked about the orthopedic implants and all that. Amaresh's colleague, Professor Bikram Bose Bikramjit Bose in IISc, he's already working with IISc with Tata Industries with different kinds of implants. It could be dental implants, it could be like ceramic implants for our knee replacement joints and all that. So my only thing is, yes, industry is evolving, and of course the entrepreneur, the investors, they're thinking in their own way. We might be at a different space where like China or India or US or Japan is, but think about just a simple example. Electric vehicle is emerging, right? So in US, we all know the company like Tesla is doing, and in all other countries, other people are doing. What the federal government is doing, they're putting like $350 million in just the charging stations so that the people are encouraged to buy the EV. They are not in a difficult position to fill in a electric charge in their batteries and wait for like half hour, 45 minutes before reaching their destination. So that is the kind of infrastructural support that the federal government can mobilize. So yes, we do have a lot of expectation from our government, but at the same time, I'm glad to see that in India and other countries, that smaller entrepreneurs are coming out and they are getting or moving into a space which is relatively out of the space of this government sponsorship. I'm not echoing any federal policy or anything. I'm not echoing that whether we should divest from public enterprise and all that. But I'm saying that, well, market has its own dynamics that is dictated by its own economics. We just have to be cognizant about that. And once again, congratulations, Amaresh. And I'm glad to see you are here in this forum. Wish you all the best in life. And
Thank you, Vimanda. Just wanted to say one thing. I think the government is increasingly also looking for these 75-25 or 80-20 models where there is also a financial incentive for companies to put in money into projects that are higher risk than they would be interested in taking up completely on their own. So that's, I think, a model that is well tested in Europe and America, and it is increasingly being tried in India, and I think that will bring much greater industry academia partnership.
Well, are we coming closer to end? Then I would seek a couple of minutes from the chair.
There is a raised hand from the student, I think. Srinivasan, please, can you speak up?
Yeah.
Sure. Okay, good evening, everyone. Good evening, Professor Chakrabarti, and thank you for the interesting lecture. I am still a student, but I am not in pursuit of any degrees anymore. I work as a faculty member in IIT Delhi. Two short questions, Professor Chakrabarti. First question is, what are the challenges that you encounter while you develop smarter products and smarter services, for instance, and then also humanize them in the sense that to increase their usability? So are there challenges in trying to make them smarter on one hand as well as humanize them to ensure better usability?
Yeah, Srinivasan, again, great that you are around. Thank you for the questions. As usual, you only ask tough questions. I think it's important that we take that right up front in account when we are even thinking about it, right? So can we bring those elements? First of all, I think we need to ask the question, why should we smart it? Why should we make it smart? What's the big deal? And if the answer, you don't have a satisfactory answer, that's not part of your requirement specification. And second is how do you make it usable? Has to be part of, again, your specification. That's for any product development. So both of them have to have a good answer why your user community should be, or some stakeholders should be interested in it. And if you don't have a satisfactory answer, see, here is an example, like the prosthetic arm that I talked about, Purak. Mr. Ignathan, my colleague there, when the Nilesh and Vinay were their first testing, right? So they got Mr. Ignathan to try it, who is a front arm amputee, right? So he has a bit of stump here, and of course the upper arm is there. So he, within 30 minutes, you could put that in, and you could start picking glasses and other objects with that. Unthinkable for prosthetic arms. It takes weeks of training before people are capable of using it. So that's happened because they took that as a design requirement right at the beginning, and not an afterthought. Oh my God, it's too heavy, or people are feeling itchy inside. Let's do something about it. The same thing is for smart. Don't put smart for smartness sake. There has to be a clear benefit that should accrue. Otherwise, don't make it smart.
So yeah, the question is more on, say, assuming that the specification list says there is some degree of smartness that is needed and there is some degree of humanness also that is needed. How challenging is that to create a happy marriage between these two? Because in some sense, they are also, should I say, contradicting, because autonomy on one hand, and then also while maintaining the human values can sometimes be challenging. That's what
I don't disagree, Srinivasan, but let's just generalize the problem. There are always conflicts between requirements, right? you want to create a light stiff beam, right? Typically beams which are stiffer are heavier, right? So if you want to make a car that is large because you want to have a lot of space inside, but you want to make it small because you can easily park them. There are conflicts everywhere. Designer's job is to deal with those conflicts, sometimes make compromise solutions. Sometimes, you know about trees, right? There are ways in which you can resolve conflicts. So again, nothing new. I mean, there's nothing special about it. There are always conflicts between requirements.
Yeah, sure. And one short question, I mean, some kind of a forecasting question. What do you foresee as the next industrial revolution to entail?
Well, next industrial revolution has already been talked about, Industry 5.0. I don't have to invent it. And that's, if you look at Industry 4.0, the discourse that Germany primarily championed, right? Industry IE 4.0. It is heavily about only automation and replacing people. Whereas if you look at the discourse that Japan brought in, the Society 5.0, you see that the humans are brought back to the forefront. How do we bring greater well-being to the society? How do we ensure that the development is inclusive? So I think inclusivity is the key. That's the Industry 5.0 as I'm concerned, as far as I'm concerned. Because at the end of the day, all of these competitions and so on are okay. But finally, we have X number of people in the world and they have to be fed. That's the global challenge. And we have to feed them in a manner without cutting all the trees and so on, that we end up not being able to breathe. So I think sustainable well-being of the society is the goal. That's the ultimate Industry X.0. Now, how do we easily achieve that? It's not easy to even assess sustainability, let alone achieve it. So those are challenges and opportunities for us to do work on collectively. Can't be done individually. It has to be cooperation rather than competition.
Okay, thank you very much.
Welcome.
I must say it is an extremely entertaining evening, spending time with all the learned people, Kamal, Amaresh, Lik, and Iman. So,
Okay, so I think we should call it a day. It was a lively discussion from different sections of the audience, different backgrounds. I also enjoyed it very much. I think over to you, Professor Ghosh, Sudeep Ghosh.
Yes. On behalf of the department and on behalf of the Centenary Celebration Committee, I must thank Professor Amaresh Chakrabarti for making time for this Centenary Lecture. Thank you very much, Professor Chakrabarti. I must also quickly mention the examples that you shared with us, the examples of innovative efforts that your teams have taken up there at IISc and got rewarded at various places. So congratulations to them also. So thank you, Professor Chakrabarti. I also take this opportunity to thank our session chair, Professor Sanjay Gupta, for making time to chair the session and lead the discussion so effectively. We had a very fruitful and very energetic.
Well, my sincere thanks for the opportunity to speak to all of you. Yeah.
Thank you.
And good to see Professor Mullik, Chudda, and all the colleagues and dadas from the earlier years. Thank you very much. Really great. All the best to Shibpur and to Mechanical Engineering Department.
Yes. Thanks. On behalf of the department also, I must thank Achudha. I must also thank Professor Mollik, Kamalda, Vimanda. There was also there. He just left a few minutes back, I think. So I must thank all the senior members of alumni, my colleagues. So with that, let's close this session. Vidyut, please take it over.
So can you please request the session chair to hand over the certificate virtually to Professor Chakrabarti?
Oh yes, I have one duty. I must request the session chair to virtually hand over this electronic copy of the certificate to our honored guest, honored speaker.
I don't know how to virtually hand over, but I can say this certificate is to you,
yes,
Chakrabarti. This much I can say.
Yeah. We'll also have a
okay, I've received it already. Thank you very much. It worked.
Thank you.
Okay.
Thank you.
Nice
Thank you all very
we
much.
had together. Yeah.
Thank you all
Good
very
night.
much.
Thank you.
Take care. Bye-bye.
Thank you very much, sir.
Okay, bye.
Thank you, sir.
Thank you very much.